Okay, so let's see how it works. So we created a fork of the EECS6446 project repo, and here it contains all the instructions on how to run the custom pod autoscaler platform. So let's just do this step by step. So first things first, let's take a look at our cluster. And right now we don't have any service deployed. So I'm going to navigate to Files, and I will actually deploy the boutique. So here I'm going to do an apply. I'm going to deploy the boutique microservices. And there you go. Meanwhile, as those services are being deployed, I'm actually going to just follow the tutorial here. So in order to deploy this, the first thing we need to do is install MongoDB. So we're going to just use Helm for that. To install that shard. There you go. The repo is added. We're going to install Mongo. And there you go. It's installed that fast. Now we can just, one of the things that we want to do is definitely port forward, like, so Mongo is running on port 27017. We're going to just forward that port so we can access Mongo in our host machine here. Oh yeah, well, I gotta just wait for the pod. It's still running. So kubectl get pods. And Mongo is still provisioning there. Should be done in a second. There you go. So now I can literally just forward the port, and there we go. And the next step is install the Mongo client. I already have it installed in my machine, but you can install it in yours. And then we're going to export the Mongo root password to this environment variable here really quick. We can do an echo on that, and we should be able to see it. There you go. This is my password now. Let me take a note of that. And finally, if I want to get inside my Mongo instance, I can literally just do Mongo, and there you go. I can see all my databases and everything. So okay, we have Mongo running, and we know our password, which is great. So I'm going to leave my password over here for now. Now moving forward to the API. So for the API, the first thing we need to do is set up API some credentials for Kubernetes. And the reason for that is that we're going to be using Kubernetes API, the Python Kubernetes package, or actually the Kubernetes API inside of the pods instead of outside. So we need to give role permission for those pods. Because this is a test environment, I basically gave admin role permissions for pretty much all the pods. So let's deploy the API. So we're going to just navigate to the API folder. And it's pretty simple. We just need to do an apply API, but before doing that, we are going to open API, and we're going to do some changes. So the only change we're going to do is actually just the password. If you want to run that locally, also as part of the README, it's important to change any environment variable that is different. So in this case here, for me, it's only the password. But obviously, as you're running in a separate cluster, in a different cluster with a different IP, also change the IP for your Locust API and also for your Prometheus API. And there you go. That's all the changes we need to do here. And we can do a kube apply. So let's come back. And let's do a get pods to see if it's working properly. And it is. We have an API, and we can even see if it's just working. So kubectl logs f. And there we go. The API is running. It's running on port 5001, being served on 5001. So we should be able to just go to 5001. And yeah, there's nothing on the main route. I also left, I believe I left some Postman file inside of this folder. So in case you're using Postman, you can literally just open it. You can click CPA, and here you have all the endpoints for this API. So let's just try one of the endpoints, the get predictions endpoint. And there we go. It's returning nothing because there's no predictions. We can also take a look for load tests. There's no load tests. And let's take a look at deployments. No deployments. Okay, that's good. The API is running. We should be able to see all the requests here. That's great. Now let's deploy the last part of the system, which is, oh yeah, we still need to deploy the front end. So let's deploy the front end first. So cd front end. And also same thing, just deploying the front end. Let's open the front end folder. Let's check the YAML file. Over here, because I'm using on my cluster IP, I don't need to change the IP, but this is the IP for my for the API that I've just shown on Postman, the one that we just deployed. Obviously, for your deployment, the IP will be different. And there we go. So let's just run this guy here. There you go. It's created. And then finally, we are going to deploy the actual pod autoscaler. So we're going to just deploy the operator at first. So let's declare this variable. Let's deploy the operator. There we go. And if we do a get pods here, we should see that everything is running properly actually. Everything is running properly. And yep, that's good. And okay, now we have the operator running. Now we just need to run our CPA, right? So let's open our CPA actually, and let's apply it as well. Same step for the CPA. Let's take a look at the YAML file. The only thing here is the password. So the password changed. Let's take this new password here, and let's paste it over here. Again, Prometheus, check the URLs there. For Mongo, like it's pretty much standard ports, the database name, no changes are needed. It's just the password and the URLs, the IPs that needs to be changed. And in this case here, we're going to deploy a CPA only for the card service. So this CPA here will be following the card service deployment, okay? And let's do that right now. So let's come back here and do a CPA apply. And there we go. And now we should be able to get pods. And we should be rolling in a second there. Okay, actually we can even do CPA service here. So cube ctl logs f, and there we go. Our autoscaler is running now. And let's take a look at our front end. So we have a front end for this project. It's running on 3001, and that's it. It's very simple front end. So what is this front end, right? Let's understand how it works. So the first thing here, we have a list of deployments that we want to follow, right? So this autoscaler function will run only for the deployments that we list over here. Right now, we have no deployments. We need to add at least one, right? So let's add one deployment. So in our case here, we made a CPA for the card service deployment. So we can go over there. So right now, the CPA is complaining there's no deployment not inside the list, so there's no deployments yet. So let's take a look at this guy. We're going to add the card service here. Okay, and then if we refresh, that's there. And if we go to Postman and we go to get deployments, we also see that card service is part of one of the deployments now. The second thing now is my function, right? And that's some pretty cool stuff. I can create whatever function I want to scale my service. So right now this is the default function. Let me just click save. The function is saved over there, but I can call whatever function I want, right? So right now the function is pretty straightforward. Like right now this function gets the last prediction, the CPU data, and the current number of replicas for the deployment. So for this deployment here, for card service, we're going to get the number of replicas, the CPU data. It's basically a dictionary that contains the CPU average consumption percentage. So what's the percentage being consumed for this deployment in terms of CPU based on the limits that were established on the deployment. And finally, the last prediction. So the last prediction is, okay, is the last prediction is actually whatever I return over here on the CPU on this side of the return. Okay, so the return is the desired number of replicas. So the first position is going to be the desired number of replicas that I want for this deployment, and the second position is my data, so my prediction. And this will be returned here and inject back into the loop as the last prediction. Okay, so let's take a look at the logs here really quick. And okay, there we go, it's working. No changes in the replica, no changes in the replica. Now let's do a load test, right? So we created this magic button here called trigger load test. So trigger load test will basically call locust for us, and we'll start triggering a load test. So let's do that. And right now, if we go to get predictions, we're going to be able to see, so get predictions it's the database table that collects all the predictions being returned over here. So everything that is being returned by this function is collected here. So as you guys can see, we have the card service with a CPU average consumption of less than 1%. The millicores, this is the number of millicores being used. This is the limit, CPU limit for this guy, and this is the number of replicas, okay? So this information is being pushed back every single time. And here, in this case of this autoscaler here, we're not using the last prediction for anything. We're just passing the CPU data. So anyways, let's trigger a load test and let's see what happens. So actually, before doing that, I have no load tests. I'm gonna click trigger load test, and there we go. Now I have a load test, and it's in my database, and the status is running. We know the exact equation that this load test is running with, the timestamp, and which deployments are running this autoscaler, this function. And so far we have no data from the load testing. As soon as it finishes, we're going to have some data. And let's take a look at this here. So as we can see, our CPA is still running. And if we keep calling the get predictions endpoint, we're going to see that our CPU average should start increasing soon because of the load testing. And right now, the way this works, the load testing is fixed. So, oh, there you go. The CPU is increasing slowly, but it is increasing. And so right now, when we click that button, what's actually happening under the hood is we can open API here, app, and it is basically triggering locust over here with this sequence of requests. So for future versions, definitely we want to make this configurable, but for now, whenever you click that, you get this sequence of tests being triggered into the deployment. Okay, so let's do this one more time. And obviously this will take a while, so we just need to wait. But as we can see, the CPU is already spiking. So I'm gonna pause now and I'll come back as soon as it's done. Okay, so the load test ran successfully. We can take a look at get load test over here. And we can go to JSON mode. And we can get the ID of the load test. And as we can see, the status changed to done. And we have all the data aggregated over here. Now we can just jump back to Visual Studio Code. And we developed a Jupyter Notebook where you can basically specify your database password and information. And here you can specify your ID. So let's get a hold of the password now. I think the password was right here. There we go. So we're going to change that. And now we should be able to plot our results. So let's just run our thing here really quick. Okay. VP disable. Okay, and now we're going to plot it. And we're going to plot this as well. And there we have it. So for this experiment in particular, there was no actual pod scaling actually over here. No pod scaling at all. But yeah, but we can catch all the values here, the average response, the number of users, everything is here coming from the database. And yeah, so this seems like our load balancer had like a bit of a higher threshold, so no scaling was actually done over there, no upscaling. Okay, so that's it for the demo. Okay, so now that we finished the demo, thanks for watching. For more information and for a step-by-step code that can be followed, just check this link on GitHub, and thank you.